Hi there, this is the practice final part 1, and as always I am the amazing Mr. Jansen. So let's take a look at this thing. If we take a look at the first example here, it says if f of x equals x squared minus 1 and g of x equals negative 2x minus 1, we want to find f of g of x, and this is what we call the composition of the function. Remember, we're doing a composition of a function. We've got a function stuffed inside of another function. So I'm going to take my g of x function and I'm going to put it inside of my f of x function. And the way that works essentially is I'm going to do f of, well, g of x is the negative 2x minus 1. And so now instead of x inside my f of x function, I'm going to plug in g of x, which is the negative 2x minus 1. So essentially what I have, f of x was x squared minus 1. But wherever I see an x, I'm going to plug in whatever's in the parentheses. Okay, whatever's in the parentheses, that's what we plug in for x. So I'm going to plug in the negative 2x minus 1. So I plug that in for x, and now I just need to simplify. This guy, since it's being squared, really it's negative 2x minus 1 times itself. So I'm going to have to FOIL or distribute and then subtract the 1. So that's going to be a 4x squared plus 2x plus 2x plus 1. And then I still have the minus 1 tag along for the ride. I combine the like terms. So that's going to leave me with 4x squared plus 4x, and then the 1 and the negative 1 cancel out, so just 4x squared plus x. Okay, and that's it. Taking a look at the next example, I want to find the inverse. Remember, the inverse is when I switch the x and the y, and then I'm going to solve this thing for y. And keep in mind that f of x and y are the same thing, so essentially this says y equals 10x minus 5 over 14. And now the inverse, I switch the x and the y, so I'm going to change it to x equals 10y minus 5 over 14. And now I'm just going to solve this for x, so solve this for y. So in order to solve for y, I'm going to multiply each side by 14. Here the 14s cancel. So I've got 14x equals 10y minus 5. And now I've got to add the 5 to each side. So I've got 14x plus 5 equals 10y. And now to finish solving for y, I'm going to divide each side by the 10. And we could leave it as one giant fraction like this, y equals 14x plus 5 over 10. And the last thing I'm going to do, I'm going to change it back to function notation. This was f of x. The inverse is denoted by f to the negative 1 of x. So I can write that again as the 14x plus 5 over the 10. The other acceptable way to have this written is to divide each piece and do a 7/5 x plus 1/2. Okay, that would be the other acceptable way to write it. Okay? Number 3, it says find the midpoint and distance of the given points. So I'm going to start my midpoint. My midpoint formula, capital M, it's going to be an x sub 1 plus x sub 2 over 2. I add them together and divide by 2, y sub 1 plus y sub 2 divided by 2. Again, it's like finding the average. I add them together and divide by how many have. So now I plug in my x values. That's going to be 1 plus a negative 6 divided by 2. And then my y values is the negative 9 plus 10 divided by 2. And I just simplify each of these. If I do the negative 6 plus 1, that's a negative 5 divided by 2 is a negative 5/2. Here the negative 9 plus 10 is a 1, so that's going to be 1/2. So that's my midpoint. And the negative 5/5 you could have written as negative 2.5 or something like that. That would be fine. Now the distance formula is the square root of, I'm going to do x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And now I just have to plug in what I know and simplify this thing. So I have to go to the square root of negative 6 minus 1 squared plus 10 minus a negative 9 squared. And now I'm just going to simplify this a little bit. Here, this is going to give me a negative 7 squared, which is a 49. Here, this is like plus a positive, so that's going to be a 19 squared. 19 squared, which is 361. And now I add those together. The 361 plus the 49 is going to be a 410. And now I'm just going to take the square root of this, and we're just going to round this to like 2 decimal places. So we'll say it's a 20.25. So there it is, midpoint and distance. For the next one, here I'm dividing two rational expressions. And remember, dividing two rational expressions is the same thing as multiplying by the reciprocal. Since these are fractions, I'm going to change it to multiplication. So I'm going to change it to multiplying, and then I flip the second fraction, so it's going to be m squared minus 2m plus 1 over the m plus 6. And I'm just going to simplify this thing as far as I can. So I've got to factor it completely. Got the m minus 2 can't be factored, and m minus 1 can't be factored. But now this numerator, the m squared minus 2m plus 1, I can factor that. So I'm going to build a bridge that gives me a positive 1. Two numbers that multiply together to give me a positive 1, but add together to give me a negative 2. Going to be a negative 1 and a negative 1. So this is going to factor into an m minus 1 times m minus 1. And now remember, I can reduce, I can cross-reduce, so anything in the numerator cancels with anything in the denominator. So these m minus 1s cancel out. And now I multiply straight across. So I've got m minus 2 times the m minus 1 in my numerator. In the denominator, the only thing left is the m plus 6. And that's it. We're going to leave it in factored form because that's the nicest way to do it, the easiest way to leave it rather than FOIL all that out. Okay? If we take a look at this one, we're adding two rational expressions. Remember, we're adding fractions. We need to have common denominators. And this is the one that's kind of like trying to be a fair parent here. If I've got 6 over a plus 3, the first thing I'm going to do is factor this completely. That's going to be 6 over a plus 3, a minus 3. And now, just like raising children, we've got to be fair to each of these denominators. We've got to make sure each of them has the same thing. And if you look, this first denominator is probably whining, it's not fair. The second denominator's got an a minus 3, and I don't have an a minus 3. So we got to give them the same stuff. They both have an a plus 3, but this guy's whining because he wants an a minus 3. Okay, so now we got to be fair, so I'll give this guy an a minus 3. And now if we look, both denominators have the exact same thing. So now it's fair. Up here, I've got to distribute the 6, so that's going to be a 6a minus 18 over, I'm just going to leave this in factored form, a minus 3 times a plus 3. Here, the 6 in the numerator. The denominator is literally just the a minus 3, a plus 3. And now that we have common denominators, we add the numerator. Denominator stays the same. So I'm going to combine like terms, the minus 18 plus the 6. So that's going to give me a 6a minus 12 all over the a minus 3, a plus 3. And the last thing I can check for here is I can check to see if this factors any further for me to cancel out. I can factor a 6 out of the numerator, which will leave me with an a minus 2. But as you can see, that doesn't help us at all because nothing cancels out. So this is just going to be my final answer. I can just leave it like that. And that's it. Number 6, it says a bag contains 6 red marbles, 6 white marbles, and 3 blue marbles. And we want to find the probability of red or blue. Okay, so remember the probability of red or blue is just the probability of red plus the probability of blue. And since these are mutually exclusive, it can't be a red marble and a blue marble at the same time. I just have to add these probabilities. So for red, there's 6 red marbles out of a total of 15, plus the probability of blue, there's 3 blue marbles out of a total of 15. And now I'm just going to add these together. I'm going to wait to the end to reduce to make sure I keep my common denominators. So I add the numerators, denominator stays the same. And now I can reduce this. They're each divisible by 3, so it reduces to a 3/5. And that's it. That's all there is to it. Okay? For the next one, it says 2 urns contain white balls and yellow balls. Why we're putting our balls in an urn, I don't know. Maybe a basket or something would be a better place for those, but that's It is what it is. The first urn contains 8 white balls and 8 yellow balls, and the second urn contains 9 white balls and 8 yellow balls. A ball is drawn at random from each urn. What is the probability that both are white? And for this one, since we're drawing from 2 separate urns, it makes these independent. So I want 2 that are white. So it's like a white. If I could spell the word white, that would be interesting. Let's see. So it's white and white, because I want a white one from each. So this is an and probability, which means I'm just going to multiply. So I do the probability of a white, and means I multiply the probability of a white. And again, these are independent events because it's 2 separate urns. So the first one for a white ball, it's got 8 white and 8 yellow. So this is going to be 8 out of 16 times. For the second urn, it's got 9 white and 8 yellow. So that's 9 out of a total of 17 this time. And now I just want to multiply these, so I'm going to reduce each of these fractions. This one is going to reduce to a 1 over 2. And it looks like that's all that's going to reduce, so now I'm going to multiply straight across. So that's a 9 over 34. And that's it. Okay, that's all there is to it. They're independent, so I just multiply the 2 probabilities. If I look at the next one, it says a jar contains 3 blue cubes, 7 blue spheres, 6 green cubes, and 7 green spheres. If you select an object at random, what is the probability that the object is green or a cube? Right? So again, or means we add, so I want the probability of green. Or means we add the probability of a cube. And now the issue here is that these are not mutually exclusive. These are inclusive, which means there's some overlap here. There are some green cubes. There are some cubes that are green. So I have to subtract the probability that it's a green cube. Okay, that it's both of those things at the same time, because I don't want to count them twice. So when I look at this, if I'm talking about the green, there are 6 green cubes and 7 green spheres. So there's a total of 13 green objects. Okay, so there's 13 green objects out of a total of 23, or means we add. The probability of a cube, I just got to look at the cubes. There's 6 green cubes and 3 blue cubes, so there's a total of 9 cubes. Again, it's out of the total of 23. And then we have to subtract the overlap. See, because the green cubes, these 6 green cubes, have been counted twice. They got counted amongst the cubes, and they got counted amongst the green objects, so I've counted them twice, so I've got to subtract the overlap. So the probability of a green cube is 6 out of the 23. And now I just combine these. I add the numerators and subtract the numerators, and the denominator stays the same. So the 13 plus 9 gives me a 22. Minus the 6 is going to give me a 16. So it's going to be 16 over 23, and that's not going to reduce at all. Okay? And that's it. So again, when there's overlap, we have to add the probabilities and subtract the overlap so that we don't count those objects twice.